What's up, YouTubers? So for today's episode, we're going to be talking about multiple pass welds. Now, I already did a video kind of covering layering beads on plate, which was part of my How to Stick Weld series, which I'll put a link in the description. If you haven't watched it, definitely watch that first, then come back and watch this video. So what I'm talking about here is the most basic form of a multi-pass weld is to be able to layer bead on plate. And as you can see here, these are overlaid very nicely. I'll even do a side shot. There's no like major peak and valley. It's almost like just a flat plate right there, okay? If you're at the point with your welding practice that you can do this without any issue, the next logical step is to practice for doing multiple pass welds. So that's what we're going to be talking about in this video. So let's get into it. So like I said in the intro, when you're at the point in your welding skill that you can pad beads on plate like this without any real struggle, you should be focusing on the skills that are required for doing multiple pass welds. Now, there's a lot of ways that you can train for this, and I'm going to share a few of them that I think you're going to find at least somewhat fun and challenging that will help you boost your skills. Now, you've seen me on the channel do like single pass fillet welds like this. Okay, I can't remember what this was from. I'm sure one of you will remember what video and what purpose this guy served, but clearly I cut it, and I probably did a cut and etch, which you can see, you can kind of see it there. Well, anyways, with a weld like this single pass weld arguably is probably not thick enough for this 1/4 inch plate. So to make this weld thick enough to have full strength on a single sided weld like this is welded both sides, but on a single side weld like this on a fillet, you may have to do 3 passes on this, depending on what rod size, or use a bigger single rod. Well, you can practice doing multiple pass welds, doing a fillet weld, or an easier way for starting out, and the way that I was trained is rather than doing like multiple pass fillet welds, which uses a lot of material. Like, imagine you had to do 20 of these just to practice multiple pass. Well, you can imagine that's going to eat up a lot of steel. Well, an easier way to do it would be to do something like this. Now, you saw me in a previous video I just released weld this up as outside corner joints in a video to help an individual get better at them. Well, this is totally still usable steel, and if I clean some of the mill scale off of this that I probably should have cleaned off to begin with, I can set this up and in a flat position weld passes and fill this all the way out like it's a giant V groove. So it's almost equal to like a V groove that you would have in like 1.5 inch plate or 1.25 inch thick steel plate. So simply by welding this pass after pass and staggering them much like on this, so you're overlapping them, we can simulate a very wide thick piece with a very wide V groove bevel on it. And this is where I would recommend to start. So this is a great opportunity to run a ton of rods, which I know we're not making anything yet with this, but the making stuff comes when you know what you're doing with this. So what we're gonna do to start off with is we're gonna do about 8, 9, 10 passes somewhere in there on this one, and we're gonna start with 332 rods, and then I'll flip this. And on this guy, we're going to use 1/8 inch rods, and I'm going to show you how to do both of those. To make this a little bit easier on me, I have you above me so that it's just a little easier. I'm a pretty big guy, so maneuvering my hands around here with the camera right there is a little hard. So we'll start out with 332 rods. Now I'm using 70/18. If you don't have 70/18, use whatever rod you have at your disposal. One of the things you need to understand though is that certain rods are much more difficult to weld when you're talking about like an open bevel groove weld like this, which is kind of what we're simulating, but really we're just training to put in multiple passes. If you were to use 60/11, You're pretty much going to have to use a wire wheel on a grinder in order to clean out the slag on the toes. 7018 on, other than the first pass, every subsequent pass will be very easy to clean the slag off and make it look good and ready for the next pass. So just keep that in mind. The 6010, 6011, you're gonna have to do a lot more work cleaning the slag out. So anyways, 332 7018 is what I'm gonna use. My first pass I'm gonna put in at 100 amps to make sure that this all melts together. I did clean this plate a little bit. There's still a little bit of mill scale in here I can't get at. For practice purposes, that's fine, but I learned a valuable lesson that I should always clean 100% of my practice pieces up, because you never know when you might do a different task. And I wasn't thinking of that, and while leaving the mill scale on this now makes it harder for me to clean it to do this practice. So with that said, let me chuck up a rod and get welding. Now you probably noticed I didn't quite make it to the end of this. And that's partially because my travel speeds forward was pretty slow. And the reason for that is when you have a bevel like this and you're trying to fill it, if you move really fast, your weld is gonna not, I guess, how do I put it, flow out. And it's not gonna give you a flat platform to weld on. So I'm feeding quite a bit of rod into that puddle to bring it up out of that bottom of that groove. So in the case of this, I didn't quite make it with a single rod. I'm gonna clean all this out, restart, and then weld it through. The subsequent passes will likely be a whole rod for a single pass without an issue. It's just I'm trying to deposit enough metal down in there to bring it up to where we have real good access to it. So I want to show you this. And this is still pretty hot, so thank God I have these thick gloves on. You see how much buildup I have off of that single pass? There's a lot there, and I apologize the camera doesn't want to focus. I can't focus the camera manually here with these gloves on. I built this up quite a bit out of the root of that. And the reason for that is that now we have a flat shelf to run 2 side-by-side passes for the next, let me set that down. Ooh, a little hot. We have a flat shelf to run 2 more passes. If I would have picked up my travel speed, it would have likely did a rounded bead in there, and then doing 2 passes on top of that would have been more difficult. And the other thing, when you have the bead flat like that, you saw how I pretty lightly hammered and got all that flux off and then used the brush just to buff it. Like I didn't have to use power tools or anything. If you do a fast first pass in that groove, odds are that flux sticks on the edge, so on the toes of both, on the weld on both sides, and it becomes so impossibly difficult to get out that even a wire wheel on a grinder won't get in there to buff that out. So you really want to focus on what I did here and get that sucker flat so that all the flux comes off easier and you don't entrap that slag when you weld back over it. All right, let me take a seat So we burned up a whole rod. I mean, there's nothing left. You probably notice, and if you don't, I'll mention it, the end of this rod was starting to glow red. We were at pretty much the limit of the amperage that would take, not to mention we did burn it down further than I normally would. But that's a good indication. When you're done with your rod, if it's glowing red at the end, you're probably running a little bit hot and or, you know, you went a little bit too far. So option-wise, I can start off on the edge here and weld into here, or I could restart here and then weld over. I think just to make this nice and flat for practice purposes, I'm going to start on the edge and then weld in. So quick look here. I pulled out the arc, snapped out a little too quick. I should have ran further forward. That's my bad. Look at that little divot I left there. Not good. But for the sake of what we're doing here, I will be able to weld over that without issue. So we can make do with that, but you want to avoid leaving those craters like that. Definitely weld all the way through and then cut it out. So that's looking pretty good. Now what we're going to do is on your lap welds like this, where we're stacking bead and bead on plate, and not lap welds, but just, you know, padding beads. If you can keep them this tight together, you can weld this groove weld without any issue. It's a little bit different. It's going to be a little bit harder. What we want to do is you want to put this next pass down right literally on the toe of this weld. We're going to clean the slag off of that, then we're going to go on the other side's toe, run it down, and ideally both beads should meet in the middle and you not have a big peak at the top of the bead and a valley on either side. So a valley in the middle or a valley on this side or this side. You want it to just flow out just like you see this. So this is 1, 2, 3, 4, 5, at least 7 passes this wide. We want 2 passes in there, and if 2 isn't enough, we might actually have to do 3. We'll see. This is a pretty wide groove here. We could have had it a little bit tighter and it would have worked a little bit better probably. But yeah, let me get this chuck back up and we will weld this. Now it's important, use all of your rod. Don't do this as a, hey, I'm going to use a brand new rod for every pass. Real life has restarts. Don't be afraid of them. You know, you want to practice those. I'm going to start by welding the one over furthest from me. If I don't stick the rod first. See how that rod is glowing red? I'm pretty high up on the amperage. I definitely will drop it. I'm at 100 amps. I'm going to drop it a little bit in a minute. Now, a couple things there. It might have been hard for you to see, but I ended up having to tip my stinger at a pretty weird angle, which directed the rod here instead of more or less here. So you want to be mindful of that, and that's something that I made a mistake on. I was still able to weld it, fortunately, and that comes from just having enough practice to be able to manipulate it just right to keep the arc going where I want it. But essentially what was going on was this rod was aimed in here, but it was then here, and the arc was literally coming through the side of the rod. Very easy to get arc blow like that, so not ideal. So always be thinking about where your stinger is. Rather than here, I would have been better off here, because then as I feed it in, what changes is the rod angle, not this way, okay? So let's clean this off. This should come off. See how easy that came off? Again, if you're using 60-11, 60-10, you're not going to have slag peel, obviously, and it's not going to be that easy to take that off. That's the reason why, to be honest, I am using 70-18 on this. Let me cool this down in some water, and I'll be right back. All right, so let's take a look at what we got here. There's still a little bit of slag in there, but I ran that pass down essentially on the toe of that weld. Now I could have had it a little bit more towards this way by a little bit, honestly, but it's looking pretty good. This top toe line, let me grab a rod here. This toe line here, I don't see, this may be a hint of undercut, but nah, it doesn't really look like it. It looks pretty clean. Same thing, you're really not going to see much undercut down here. So now we're ready to do the next pass, and I'm going to do a slight, if this is straight in, this is straight in. I'm going to do a slight angle like this, just ever so slightly, and I'm going to run the bead right down here. We've essentially created a shelf for the the third pass to lay in there. Now, I really like the way that this looks here. When we get to here, when you start getting this tight, that could be somewhat of an issue. If you move too fast or don't run enough amperage, when you weld over this, you could end up getting lack of fusion in there where it basically the metal bridges these two parts and doesn't melt in there. This would be a highly likely place to have lack of fusion. How I'm going to avoid that is making sure I'm running enough amperage, and since I know it's there, I'm really going to focus on trying to do what I can to see that it's all melting together there. And this is 100% due to that rod angle change. I started, and I'll show you here, more or less about like this angle. Here, I'll tip it where there. Okay, and as that rod burned in the stinger, I started doing this, and look where the bead is. Rather than up here, it's pushed tighter to here versus, see that? So this is 100% due to that inadvertent rod angle change. So now that I know I had that, I'm going to chuck the rod in a stinger in a different, and have the stinger in a different place, but we'll just run it down here. I'll run this pass, we'll clean it up, look at it, then we'll start getting some arc footage. All right, I dropped it to 95 amps from 100. So let's take a look at what we got here. Now I got a little bit of a divot right there. See how that's a little bit lower there? And that's where I had that kind of botched tie-in. You can see how it's a little bit lower. Now I'll still be able to fix this when I weld extra passes on here, but it goes to show that the cleaner your base root pass is, the better everything goes. You always want to get the root as good as you can. A little bit of spatter in there, not too bad. I did drop the amperage a little bit. At the end, I started to get a little bit of arc glow, but the rod was pretty much gone at that point, so I snapped out of it. This is about the length of weld that you're going to get, which I think this is a little over 5 inches. I'll measure it later. But guess what? The rod didn't make it to the end. Now, ideally, if you're going to do a tie-in, you'd probably want to do it here rather than just, you know, it's going to be very difficult to get a clean weld in here and make this look decent. So rather than, you know, restarting and doing a 1/4 inch weld that's likely going to be humped up quite a bit, if you can do a tie-in, do it over here and then weld in. But for practice purposes, I'm probably not going to go back and do anything here. It really doesn't, for practice, doesn't really make a difference. Now when we look in there, we'll look down it. See how nice and flat that is? And it's going to be normal. You see how it's not exactly split down the middle? That's totally normal, and that's because this was the last pass that we put in there. But now we're going to do somewhere between 3 and 4 passes. Because this is a slightly different angle, it may take 4, but I'm going to try and do it in 3. The key is that we're going to have 3 or 4 flat, nice passes just like we've been doing. The hardest part is already over with. If your root doesn't go in well and it's, you know, not fused and kind of like zigzags between the 2 plates, grind it out and redo it. Like I'm telling you, the root sets the tone for the whole thing, and if your root's trash, don't even bother doing multiple pass weld on it because you're not going to be able to straighten it out much. Well, I'll get set up for some arc footage now. So the key thing here is to establish your molten puddle, and you can see it's kind of like an eye shape, maybe a little bit round and about twice the length that the electrode is wide. And you just get it to where it looks like that, and then you slowly move forward and feed rod in to keep it the same size as that. Literally, that's all there is to it. And I'm kind of favoring a little bit of a push angle towards the upper part of the plate there, just to kind of get it to wet out, but just traveling smoothly along. All right, so the first pass in there, I thought I was recording, and it actually wasn't recording, of course, so mistakes are made. But the second pass is what you saw. Oh, a little bit of flux there. I'll clean it off in a second. This is the pass you just saw. So the second pass went in pretty good. You can see there's a little bit of a valley here. Now, I am running at 95 amps. I tend to run hot, especially on 1/4 inch. I rather, you know, have ran the first pass in there, especially with this cooled off with some water at 100 amps, 105. And I would have found that that would have flowed out a little bit better. But I don't see any evidence of undercut. There's a little bit of a, not a cold toe, but little irregularity there. Not really a huge deal, honestly. The second pass went in a lot better, very clean. And then I know that this third pass is going to go in real nice since there is a little bit of a preheat here. If you notice, the gap here to here is a little bit bigger than it is down here once again. It's doable, not really a big issue. I'm going to have to slow my travel speed here in order to fill that, and then I will have to pick up my travel speed a little bit here in order to get things to where it's somewhat flush and flat. And that's simply because if you look at the distance here versus see how close that is there, it's just my start. I should have ran it a little bit more in the middle, you know, but that's all fixable. We can go back over here and run it. Now, I did reverse this plate. This was this way, and if you remember, this was starting to, due to running out of rod, it was kind of cut off a little bit, but by starting here, it allowed me to have a fairly flat weld end to end where there isn't like a massive drop off cliff here. And here, I'll bring that up. If I wire wheeled it with a grinder, it'd look a little bit better. Looks a little rougher than it really is. And of course, zoomed in with a camera, you can see any flaw in that, but we're looking really good. This is about what you should be aiming for. So I'm gonna get set up again, and I'm gonna run a pass down here, and we'll watch it. So for the first part of this weld, I'm going to be traveling a little bit slower than the second half. And the reason for that is just to fill in that little bit wider of a gap between that second pass and the wall of the bevel. But you can see I'm just dragging that molten puddle, that molten eye, along nice and slow. So let's talk about what we got so far. So we did a 6 pass. Yep, 6 passes, 3, 2, and then 1, so 6 pass, I can count. 6 pass groove weld, which this also would be similar to doing a fillet, slightly easier than a 6 pass fillet weld with 332 rods. And you can see how they're all overlapped. When you look down it, you can see it's this last bead I put in is a little bit humped up compared to the other two. I would have liked to ran instead of 95, I should have went back to my 100. That just seems, I don't know, I tend to run them hot and I like it that way, but that's not too bad. You can see the toe of that's a little bit cold. It is wetted in there, so not really anything to worry about. And if I were to do more passes on this, I could go right over that, bump up the amperage a little bit. We'd be in real good shape, so I'm not too worried about it. Looks good overall. I did use for this last pass a 7018 that I had just laying around on the workbench that's been out of either a rod oven or in its container for like, I don't know, a month. And without a doubt, it ran different than the ones that came straight out of a brand new can. So I don't like the way it ran. Near the end here, I started to get some arc blow, it seemed, and I was able to manipulate a little bit, but it just didn't seem to run as good as the other ones, and they're the same rod. It's just they weren't held in factory containers, so probably picked up some moisture. But again, this is what you should be aiming at to do. Now you can see this is actually starting to close and bend itself shut because of the pulling of the metal as it solidifies. And the groove was honestly a little bit too wide anyways. The angles were a little bit off. But yeah, that's what we have so far with 332 rods. I would recommend burn this whole thing out, all the way out flush with 332 rods. I know it sounds terrible, it's boring, you're not building anything. But when you hit out here, you're gonna be looking real good for your skill level. You'll get this really good. Trust me, it'll carry over. So now what I'm going to do, I'm going to clean up this mill scale, and then we're going to do, I don't know, 3-4 passes with 1/8 inch rods. It'll be a little bit different, but much the same, so let's do it. I'm really happy with how this arc footage turned out. You can definitely see what's going on. Now with the 1/8 inch rod, the puddle's more clearly defined simply because, well, it's a bigger puddle. And you can see it's just staying the same shape as I slowly drag it along. And the reason it's staying that same shape is because my travel speed forward, as well as how much rod I'm pushing in, is staying roughly the same. And that's what you want. At the end of this weld, you're going to notice some arc blow. You'll listen and the arc's going to sound different, and you're going to see buckshot BBs flying out. All right, so that root pass went in okay until it hit the end. I experienced some arc blow. I'm sure you saw that. And I know I've been talking about arc blow a lot, and it's worth it to mention why this is happening. So partially, I did a pass on this, and inside of there is probably pretty scabby material. Had I taken a angle grinder with a flat disc, not a flap disc, but a flat disc, a cutoff wheel, and ground into there to get the clean metal, it probably wouldn't arc blow as bad occasionally. The other thing is that I'm at the end of the table here to get the best shot for video footage, and my ground clamp is on the complete opposite end of the table. And as I'm welding here, what can happen is the path to ground, like ground doesn't take a singular path, or the electricity doesn't take a singular path, it takes multiple. Well, as the electricity is flowing through everything here and this plate gets red hot, oftentimes the arc can wander to one side or the other, which causes the rod to blow out and you get a long arc, yada, yada, yada. You get the idea. So by positioning this further onto the table or relocating my ground closer here would probably take care of it. It's just I can't do that and film it because everything, you know, I can't fit it all in this little area. But that's looking pretty good if I could get it to focus. You can see now I didn't arc footage the first root pass with the 332 rod, but the end result with the first pass there, this looks a lot better. And I just find on 1/4 inch plate, 1/8 inch rods wet out better. You're running a higher amperage. I don't see any evidence of cold toes. And look how nice and flat. And here, let me click on this damn camera. I don't know why. Maybe it'll focus now. Let me zoom out a little bit, then it will. Sorry about that. Whoa. There you go. Sorry about that, guys. You can see how nice and fairly flat that is. We're looking really good. So let's run 2 more passes on this. Give me a thumbs up if you like good arc footage. I got lucky again. This turned out great. Anyway, you can tell start to finish that molten puddle stays pretty much the same. And that's a good indication that everything's going real good. I like how easily distinguishable the 7018 weld pool is. You should be seeing this in your helmet or hood while you're welding. If you don't, your shade might be too light or too dark. So let's take a look at what we got pretty quick. So pretty equal width here, next down a little bit in here, and then equal back up through here. And if you can see, we'll use the edge of this as a guide. Yeah, you can see the bead kind of, rather than coming up here, just came down a little bit. Not really a huge deal. If you notice, virtually no cold toes, beads looking real good. Let's run the final pass on this and then go over what we find. So start to finish on this weld is pretty much perfect, really not much more to say. If you can do this all the time, you're really doing good. All right, so let's wrap this video up and talk about what we found and what we learned. So here are the 3/32 passes. They went in okay. The toes, the edges of the weld are a little bit cold to my liking. Now, I'll be completely honest with you guys. I don't really run 332 rods very often on 1/4 inch plate. Like, there really isn't much of a reason to, simply because, well, for one, too many passes, and two, I find that welding this thick a plate, you tend to get, you know, the colder toes, and you definitely can't say I wasn't running them hot. I mean, I had them at 105 for the root and 100 for going in there, and it just, you know, you're at the limit of what that rod can handle for amperage, and I can't boost more amperage up because the rod was already glowing red near the end, so I had the amperage. And yeah, I could have traveled a little bit slower and smoother, and that would have helped. But again, you know, it's not looking too bad. It's just not the preferred method that I have, but it is functional and you can totally do it. It's just 1/8 inch rods run a whole lot better. So let's look at that. And the 1/8 inch rods, which I can't remember which way I was welding it, and I still have a lot of dust in there. I could, and even rust since it contact rusted, dipping it in water. But you can see the overall beads are far flatter with the bigger rod. Only 3 passes it took to get to where that is, which this 332 is a little bit taller, okay? But, you know, far more metal every pass, far easier. And I was running these at 125 amps, and you look at the tow line and it's like a laser beam. I mean, other than a little bit right by my finger right here, and that's barely a defect. I mean, it's exactly what you want to see. So 1/8 inch rods are definitely the way to go with this 1/4 inch plate. It's just easier, and it welds nicer, piers nicer, etc. You get the picture. But you should really practice with something like this. I mean, you can do your outside corner joints like I did, and then you can do 332 on one side, 1/8 on the other, and fill this bastard all the way out. And I know that sounds like a lot, and it is. Okay, I'm not going to deny that that's a ton of welding you have to do, and probably 20 pounds of rods in total. Who knows, 10 pounds at least anyways. But this is what will make you a better welder, because once you can do this in the flat position, if you ever have to do a V-groove bevel weld on something thick, even if it's 3 passes or 12 passes, once you can do 3 passes great like I did here, then, I mean, without a doubt, I could do a 20 pass weld, 40 pass all the way out, and it's all gonna be the same just like that. So the key is perfecting the first part of it. So get your 3 to 5 passes down perfect, and this is going to help you out tremendously. And once you do this, you can carry your knowledge over to doing fillet welds multi-pass, because it's very much the same as this. The difference is your rod angle has to be more towards the upper plate here in a fillet weld than what we do here, since it's in the flat. And with that said, I wanted to share something with you. Now, this is something that I did back when I was in school. I can't believe that this isn't completely rusty now, since it's been sitting around a very long time around my shop. But this is essentially 4 plates, and this was twice the height. I don't know where the other piece is. I actually welded this on as a business card holder, but that's besides the point. This was pieces like this in an X pattern, and as assignment, you had to weld this whole thing out with, I believe, that looks like 7024 or 7018. That looks like 6013 maybe. This is probably 6011 or 6010. This is 6011, this is going to be 6010. And we had to weld this whole thing out. And mind you, this is only half of it. So you can imagine the hours and hours and hours of welding on this. And then it was saw cut in half. And if you had any major signs of porosity, you would get docked points. Now, some of those spots look like porosity. It's just filth on this. This thing's been sitting around for a while. But if I recall, I only had like 1 or 2 very minute bubbles of porosity in this whole thing, which I kind of was surprised at. And I definitely didn't clean this as good as I should have. And that's all stuff that you learn, you know what I'm saying, especially with 6010. But it wouldn't hurt to do something like this. And this was done, I believe, if I recall, this one was in a flat. I had to do one in the horizontal position, so welding like this. And then I had to do one vertical up, and I had to do one overhead. So I don't even recall, like this is probably 10 hours, 15 hours of welding. This right here, if you do one of these, will make you a hell of a lot better of a welder. Like by the end of it, there's no way that you won't be able to weld decent. And I know it's tedious, I know it sucks, but this is what separates, you know, people who can weld good from people who can't weld or aren't that good at welding, is doing something like this, you know, and then cutting it in half and seeing what you have. You know, the proof's in the pudding. Anyways, with that said, thanks for sticking around for the video. I hope you guys learned something, and get out there and practice some of this stuff. You will be a better welder for it, trust me. And I also learned, I'll put it in the mix here, that I need to weld with 332 rods more. I'm not as good as I should be with them. 1/8" rods, of course, anyone can lay a 1/8" 7018 weld good, but the 332s are harder. So if that's what you're working with, expect to have more of a challenge, I guess. So anyways, thanks for sticking around. Until next time, guys.